Welcome to today's Reddy Maths YouTube video training. Something a little bit different today. It's mental mathematics for teaching assistants and teachers, day 8. What we're looking at today is tips and tricks for mental addition. Just 3 little tricks that really help develop your mental addition skills that you can pretty much use whenever you're faced with certain mental arithmetic challenges.
Good morning and welcome to this week's day 3 of the Reddy Maths YouTube training. Overall, this is actually day 8 of the mental mathematics strategies that we've been looking at over the past 2 weeks. Today is very different. We've kind of had the first 7 days working on a very similar theme where we've looked at wrapper code, MC wrapper code and number. We've looked at round and adjust. We've looked at counting on. We've looked at double and adjust. We've looked at partitioning. We've looked at number bonds. And then we've looked at manipulating the calculation. That's taken us 7 days. What we're doing today is just something a little bit different. We're just going to look at 3 little tricks that are just quite helpful to know. There is understanding behind them, and I will go into that understanding. But actually, it's just nice to have a trick that always works, that gets you an answer to what looks like quite a complicated calculation. So today we are looking at number tricks and tips.
The first tip and trick is concerned with consecutive numbers. Basically, if you're given a string of consecutive numbers, how can you add it together really quickly? If you are faced with having to add 7 plus 8 plus 9 plus 10 plus 11, how do you know straight away the answer is 45? If you are asked to add 25 plus 26 plus 27, can you get the answer 78 really quick? What strategy would you use to be able to add strings of numbers incredibly quickly? There's a nice little trick that we're going to be looking at over the course of this session. To start off with, just to get used to consecutive numbers, which are often known as Nextdoor numbers, or numbers which are next to each other, we're going to start off just by looking at adding 2 consecutive numbers. Rather than me give you 2 numbers to add, like 4 and 5, or 26 and 27, that would be a little bit too easy based on what we'll be doing this week. What I'm going to do is give you the answer, and I'm going to ask you what's the question. So which 2 consecutive numbers give the following totals? Have a look at 9, 21, 15, 31, and 49. There are 2 numbers that are next door to each other, 2 consecutive numbers, which will add together to give each of those totals. If you pause the video now, have a little play with those numbers and see what you come up with. So hopefully you realise that to get the total 9, you add 4 and 5. To get the answer 21, we add together 10 and 11. That 7 plus 8 is 15. That 15 adds 16, give a total of 31, and that 49 is 24 plus 25. They're all relatively easy ones to do because those numbers are all quite small. But do we have a general strategy that can be used for any odd numbered total? If I was to say what 2 odd numbers add together to make 347, what strategy would you use? If it was 251, what strategy would you use? Have a look at those numbers, just pause for a second. Can we think of any general strategy that will always work? Hopefully you came up with one of these 2 options. The option that I tend to use is I look at the number 9 and think, well, what number comes before it? 8. Well, a half of 8 is 4, and then 4 add 5 equals 9. The idea behind it really is that half of 9 is 4.5. So if you have that number, 4.5, what are the numbers on either side of it? It's a 4 and a 5. The other option is to add 1 to the number. So 9 and 1 is 10, half that, 5, and that gives you the second of the numbers. So again, it gives you 4 and 5. So similarly with 21, a half of 20 is 10, that gives you the first number. Add 11, or a half of 22 is 11, and then subtract 1 to give you 10. On to 15. What's a half of 15? Well, 7.5. What's on either side of it? 7 and 8. Much easier, though, to either half 14 or half 16. For 31, we either half 30 to get 15, or we half 32 to get 16, and adjust either way. And for 49, we either half 50 or 48, which will give us 24 plus 25. So it is a really, really good strategy, really easy to use. If you've been given a total, you can work out which 2 numbers add together. It's kind of the opposite of double and adjust, really. It's using the idea of double and adjust, but going the other way around. So your little challenge is now to apply that rule to 65, 101, 265, 889, and 765. Again, just pause the video there, have a look at those, spend a few minutes applying either whichever of those two options you prefer. So, what's a half of 65? Well, what's a half of 65 will be 32 and a half, but a half of 64 is 32, a half of 66 is 33. Therefore, we get 65 being 32 and 33. 101. Well, half of 100 is 50, so it's 50 and 51. 265. Well, a half of 264, interestingly enough, is just 100 more than 65 at the top. It's 132 and 133. You can see how those two answers link together. 889. Well, let's make it 888, which gives us 444 and 445. And let's look at this one. We're now on 765. So how's that one going to link in to the others? Well, a half of 700 is 350, and a half of 64 is 32, as we've seen before. So now we've got 350 and 32. And again, that does link to the previous answers above. If we just take that first answer of 65 is 32 and 33, well, we've now got an extra 700, so it's 350 plus 32 and 33. Really easy little rules to apply. It's a little bit different to what we're going to be looking at for the rest of the session. I thought we'd just start off just by getting into the idea of what consecutive numbers are all about. Part 2 of our consecutive number tips and tricks is the main part of the session, adding 3 consecutive numbers. We're now going to go to the ready-made classroom and have a look at some tips and tricks for adding 3 consecutive numbers really, really quickly.
A series of relatively easy calculations, especially if we employ some of last week's strategies, and then one that does look a little bit harder at the top. I'm actually going to start with the one at the top. I'm going to pause the video in a second. Now, it's a look at those long string of numbers, and just based on what we've done so far, what would you currently do to add all those numbers up? What would your strategy be? So you've got 3 plus 4 plus 5 plus 5 plus 6 plus 7 plus 7 plus 8 plus 9 plus 12 plus 13 plus 14. Have a look, jot them down, find a quick strategy. It's probably one of the ones that you've used before, and let's try and find a quick way to get the total through those. Now, as I was looking at the numbers on there, the first thing that jumped out was that double 5. So I'm going to circle the 2 5s, which makes a 10. Looking at that number bond strategy, we could do any of the others. We could do the double and adjust, but let's just see how many number bonds we've got. Well, there's a 14 here, and that's going to go with that 6. So that's going to give me a 20. I've got a 13 here, and that's going to go with that 7, and that will give me another 20. We've got 12, and that's going to go with the 8, which goes there, and that's going to give me another 20. So we've already got 20, 40, 60, 70. What we've then got is going to use a different coloured pen. For this, we've then got the 3 and the 4, which is 7, and double that, which is 14. So I can write down 14 here. All right, I shall write it there, 14. 20, 40, 60, 70, so 70. Add 14. And then finally, we've just got the 9 at the end. What's our strategy for adding 9? I'm just going to write the whole thing out. We've got 70, add 14, add 9. So I'll write the whole thing out. 70, add 14, add 9. 70 and 14 is 84. Our strategy for adding 9 is add 10, take 1. 94, 93. So that gives us a total of 93. There's probably quite a few ways we could have done it, but that might be the easiest one. What you may well have noticed as well as the number bond is that there's quite a few little strings of numbers in there. We've actually got 3 plus 4 plus 5, which is 3 numbers that are what you would call consecutive numbers, numbers that are next to each other in a line. You've then got 3 more consecutive numbers, 5 plus 6 plus 7, and then 3 more consecutive numbers, 7 plus 8 plus 9. Finally, we have a third set of consecutive numbers. And that brings me to the first trick that we're going to look at today. How do we find the total of numbers that are in a string consecutive numbers? So, you know, not 7 plus 4 plus 12 plus 52, but 3 plus 4 plus 5, 5 plus 6 plus 7. Now, obviously, when the numbers are quite straightforward like these, you can just add them in your head. But is there a quick way that we can do it? So the first thing I'm going to do now is I'm just going to pause the video and we're going to look at these ones going down the left hand side. And all I want you to do is just add them up, just using normal simple number bonds and normal strategies. Just add up all of those and let's just see what we notice about the totals when we get them. What I've done there is just put the totals. I hope they weren't too hard to work out. 3 had 4 had 5 and 5 had 6 had 7 and so on. What I wanted to think about though is what do I notice that connects all of those totals? In fact, if I just fill the next one in as well, if I do a number bond, quick one here, if I put the 1 with the 19, that gives me 20, 40, 60, and that gives me a 60 there as well. What do I notice about 12, 18, 24, 39, 60 and 150? Is there something that connects them all? Is there a link between all of those totals? At first, if we hadn't got the number 39, you might have looked at the answers 12, 18, 24 and 60 and thought, it's something to do with the 6 times table. And the number 39 comes out. What about 6 plus 7 plus 8? Well, 6 and 7 is 13 and 13 and 8 is 21. So that again isn't a multiple of 6. But what are they all multiples of? All the totals are multiples of 3. So 21, 12, 18, 24, 39, all multiples of 3. Let's just, again, get a different coloured pen and just jot down what the particular multiple of 3 is for each of them. So 21 is 3 multiplied by 7. So I'll put up 3 there. 12 is 3 multiplied by 4. 18 is 3 multiplied by 6. 24 is 3 multiplied by 8. 39 is 3 multiplied by 13. 150 is 3 multiplied by 50. And 60 is 3 multiplied by 20. Now, looking at those numbers, there doesn't seem to be any connection between them at the moment. What I want us to do now, I'm going to pause the video again, I'm going to look at the numbers that we're multiplying 3 by, and now look back at the numbers that we're adding up. Can we make a link between any of these sets of numbers, or each of these sets of numbers, and the number that we multiply by? And again, we'll just pause the video, have a quick look. And what we've now got to is the first of our maths tricks of the day. There's the multiplier by 7, so it's 3 times 7, and look where the number 7 is. Directly in the middle of our consecutive numbers. 4 multiplied by 3 is 12, 6 multiplied by 3 is 18, 8 multiplied by 3 is 24, and so on. And that's just one of those tricks that's really worth knowing. If you've got any 3 consecutive numbers at all, they can be consecutive decimals, they can be consecutive normal numbers, they can be consecutive multiples of 10. 40 plus 50 plus 60, as long as they've got the same gap between them, all you do is you take the middle one, multiply it by 3, and you'll get the total. Absolutely brilliant trick. So again, it does work obviously for any consecutive numbers, but it certainly works for any numbers that have the same space between them. So even if I was to say what's the total of 5, 7 and 9, the total is still going to be 21. 5 add 7 add 9, the answer will still be 21 because they've got the same amounts of space between them. 5 add 2 is 7, add 2 is 9. So it's interesting, we can have different things on either side of that 7 and the total will still be 21. If I was to write 4 plus 7 plus 10, the total's still going to be 21. There's a gap of 3 and a gap of 3. 7 times 3 is 21. We can check that. 10 and 4 is 14 and 7 is 21. We're not going to look too much at that though, that's kind of going into greater depth. We're going to stick today mainly just looking at numbers that are in a normal consecutive number string. It's one of those really good tricks that's worth knowing. What we're going to do now is actually look at why it works. It isn't just a trick, there's got to be some great understanding behind it. So again, if we are teaching children this particular trick, we can't just say, look, get a string of 3 numbers, find the middle one, multiply by 3, boom, answer. You know, it works every time. Obviously it does, but what we do need to know is why. So I've set up a few different examples that we're going to look at over on the table. What I've done now is I've actually set up visually the first couple of examples, well actually for all 4 of those examples. We're just going to look at them now and see why they actually work. It's actually quite simple. It is an example of manipulate the calculation really. We've got here 3 cakes, 4 cakes and 5 cakes. But if I wanted to put them into a nice even array, I've just moved that one over there. So what I've actually done is I've looked at the middle, which is 4, This is 1 less than 4. This is 1 more than 4. If I pass that one over there, I end up with 3 4s. And that will be the same for any 3 consecutive numbers ever. You'll always have the middle number, you'll have the one below it that's 1 less, you'll have the one above it that's 1 more. Therefore, it must be the same as the middle one multiplied by 3. So that is now 4 multiplied by 3. I generally tend to use cubes if I'm showing children, just for ease and for speed. So I'll have a tower of 3, a tower of 4, a tower of 5, and I'll just say, look, if we move that one over there, we can see that we've now got 3 4s. Because that tower of 3 is 1 less than the middle, the tower of 5 is 1 more, we can pass it over here and we end up with the same amount on each. What's lovely about this also is because it's colour coded, you can clearly see where that green one has come from, so how it's actually been made up. If we now move on to the egg boxes, we can see 5 plus 6 plus 7. That works in exactly the same way. We've got 6, we've got 1 less than 6, and we've also got 1 more than 6. Pass over the extra one, and again we can colour code it and see where it comes from. We can see that we've now got 6 multiplied by 3. That works, you know, whatever numbers we use, you will find the same principle. Set the other two up with cubes and with a Numicon. I quite like the Numicon one. We've got a 7 and an 8 and a 9. I always like the idea of showing a Numicon piece in a different way. And that again is showing the 9 piece is 8 plus 1. We can see that the 7 piece is 1 less than 8 just by looking at it. Again, what we're doing is we basically take that 9, we put the 1 over there, and we put the 8 back down there. And so you end up with exactly the same thing. You end up with 3 8s. What we can then do, again, is we could replace that with an 8 to show that's what we've ended up with. On to the next one, 12 plus 13 plus 14. Why is the total 39? Quite simply, I haven't quite colour coded this one the same way, but I've got a 12, a 13 and a 14. We're going to take that one from there and put it over there. Ooh, you end up with, put these back together properly, you end up with 5, 10, 13 multiplied by 3. It works with bigger numbers as well. Interestingly though, this is actually no different to the cakes. It looks on the surface like 4. Wait a minute, let's put this the right way around, that'd be a good start. It looks on the surface like 4 plus 5 plus 6, but actually each of these is worth 10 sweets. It's 4 10s, 5 10s and 6 10s. 40 plus 50 plus 60. How much altogether? Well, it's 50 multiplied by 3, and therefore it proved it. There's 150 sweets. Altogether, really, really simple. Love this strategy, and we're going to look shortly at how it develops. What I've done now is I've had a little play with the numbers that we started off with. We know the total is 93, we'd already worked that out. So I've just applied that strategy we've used. 3, 4, 5, that's 4 times 3. 4 multiplied by 3. 5, 6, 7, 6 multiplied by 3. 7, 8, 9, 8 multiplied by 3. 12, 13, 14, 13 multiplied by 3. What we ended up with then was a nice easy number bond. 12 and 18 is 30. We did a count on. 30 and 24 is 54. Beautifully, it left us with 39. Round and adjust. 54 and 40 is 94. Subtract 1. That is 93. Or manipulate the calculation, just pass 1 over. 53 add 40 equals 93. Again, it's just a great trick to know. What I'm going to look at now is, where does it go? Can we develop it further? I'm going to give you a chance to have a try and a little play with some of your own.
So just to reinforce what we've been doing previously, can we quickly find the total of 2 plus 3 plus 4, 7 plus 8 plus 9, 10 plus 11 plus 12, and 14 plus 15 plus 16? As you've just seen, there's a very, very simple way. We can just do the normal addition, of course. 2 add 3 is 5, and 4 is 9, and so on. But we end up with that 2 add 3 add 4 is 9, 7 add 8 add 9 is 24, 10 add 11 add 12 is 33, and 14 add 15 add 16 is 45. As we've just seen, the first thing you could ask children, if you do quite a few examples, is, what do you notice? So as we spotted, all totals are the middle number multiplied by 3. So 2 plus 3 plus 4, 3 times 3 is 9, 8 multiplied by 3 is 24, 11 multiplied by 3 is 33, and 15 multiplied by 3 is 45. As we looked at earlier, it's just a really easy way to get the total for any 3 consecutive numbers. Why does that work? Well, that's what we looked at in the classroom. We looked at it in many, many different ways. I just thought it would be worth just very quickly reinforcing those. For 2 plus 3 plus 4, the 4 is the same as 3 plus 1. And if we pass that 1 over, we end up with 3 3s. 7 plus 8 plus 9, you can see straight away 7 1 less than 8, 9 1 more than 8, so we pass 1 from the 9 over to the 7, and we end up with 3 8s. Exactly the same with the towers of cubes, 10, 11 and 12. We pass 1 from the 12 over to the 10, and we end up with 3 11s. That's why all we need to do is multiply the middle number by 3. Now it's time for a little bit of practice. We know the strategy, we've practiced it, we've seen it a couple of times now, we know what to do. So if we are faced with any of these slightly more complicated strings of numbers, can we very quickly find the total? I'll just pause, let you have a look, hopefully work these out very, very quickly. Let's have a look. 8 plus 9 plus 10, well 9 times 3 is 27. 25 multiplied by 3 is 75. 150 multiplied by 3 is 450. And 300 times 3 gives us a product of 900. Let's now, though, go to a bit of greater depth. This is a little bit like we did at the start, but now we're working on 3 consecutive numbers. Can you work backwards? Which 3 consecutive numbers will give you these totals? So obviously, what strategy or rule are you applying to get them? So if we know the total is 12, 30, 60, 48, or 93, what are the 3 numbers that we're adding together? We just need to think backwards, really, and reason a little bit about this. Again, this is really good to do with children who've understood the basic rule. Let's go the other way. Have a little think about it. So we've got the number 12. 12 is the total. Something multiplied by 3 is 12. Hopefully, we know that one is going to be 4. So it's 3, 4, 5. The total is 30. Well, 30 divided by 3 is 10. So that's 9, 10, 11. 60 divided by 3 is 20. 19, 20, and 21. You can see the link between the 30 and the 60 and the numbers in the string there. How would 90 look? Again, you can make a link with 30, 60, and 90. 48 is a little bit trickier. What do I multiply by 3 to get 48? Well, the answer to that is 16. But even if we didn't know, we might know 45 is 15 times 3. And the last one, 93 divided by 3, gives us 31. So it's 30, 31, and 32. Once we've got that idea, it's a nice way of extending your more able children or your children at greater depth to develop an understanding of the strategy. This is just a little bit of homework. I'm not going to give you the answer to these. Just have a little look at them yourselves. Just apply that strategy. The third one is probably the easiest one. The fourth one's quite easy as well. The first, the second, and certainly the last one are a little bit trickier. It's going to take you into a little bit of division as well. But always worth giving that one a try.
Well, let's have a look where this little trick goes to as we move it a little bit further. What I've now got are 5 consecutive numbers. 4 plus 5 plus 6 plus 7 plus 8. 9 plus 10 plus 11 plus 12 plus 13. And the final example is 7 consecutive numbers. All I want you to do is just work out the totals using normal methods. And then, can you spot a little trick that links to the previous one that we saw a few minutes earlier? Again, have a quick look and then we'll just look at where the trick comes from. Hopefully what you've seen, adding the totals up, they equal 30, 55 and 28. And the strategy is very, very similar to the one that it is with adding 3 consecutive numbers. 4, 5, 6, 7, 8, and I hope we spotted, that's 6 multiplied by 5. 9, 10, 11, 12, 13, 11 multiplied by 5. 5 consecutive numbers multiplied by 5. 7 consecutive numbers, find the middle number and multiply by 7. Really, really nice strategy. Again, let's prove it. We'll just come over to the desk over here. And I've got, first of all, 1, 2, 3, 4, 5, 6, and 7. And over here, so I'm going to go 1, 2, 3, 4. That's the one in the middle. That's 1 less than 4. That's 1 more than 4. Pass it over. That's 2 less than 4. That's 2 more than 4. Pass those over. That's 3 less than 4. And this is 3 more than 4. Pass those over. And what we can now see is 1, 2, 3, 4, 5, 6, 7, 4 multiplied by 7. Over to this example, which is 9 plus 10 plus 11 plus 12 plus 13. We said it was 11 multiplied by 5. That's because this is the middle, which is 11. That's 1 less, and that's 1 more. I'll just pass that one over there. So we've now got 3 11s. This one's 2 more than 11. This one's 2 less than 11. And again, what we can now see is we've got 11 multiplied by 5. Great strategy to know, and will work with any set of consecutive numbers as long as it's an odd set of consecutive numbers, because obviously we wouldn't have a middle if it was an even set.
Now again, as we looked at earlier, what happens when we've got 5 or 7 or indeed 9, 11 consecutive numbers? Well, as we saw, it's the same strategy but just adapted for the number of consecutive numbers in the string. Can we quickly find the total of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12, 13, 14, or even 7 numbers, 3, 4, 5, 6, 7, 8, 9. As we looked at, it's the same idea, but because there are now 5 numbers in the string, we take the 4, we multiply by 5. So let's have a look. 2, 3, 4 times 5 is 20. 7, 8, 9 times 5 is 45. Why does it work? Well, it works because the 10 is 1 more than 9 and the 8 is 1 less than 9. We pass 1 over, we end up with 2 9s. Same here, that's 2 more than 9, that's 2 less than 9. So we pass 2 from the 11 to the 7 and we end up with 9, 9, 9, 9, 9. 9 multiplied by 5 is 45. Imagine how quickly we can do this now. What's 10 add 11 add 12 add 13 add 14? It's just 12 times 5, it's 60. Even with 7 consecutive numbers, the strategy still applies. The middle number is 6. 3, 4, 5, 6, 7, 8, 9. What's the total? Simple, it's 42. Why? Well, here's our 6. 1 less than 6, 2 less than 6, 3 less than 6, 1 more than 6, 2 more than 6, 3 more than 6. They all cancel each other out. It's like passing 1 over, passing 2 over, and passing 3 over, and you end up with 7 6s, or 6 multiplied by 7, which is 42. So that will work for any string of numbers that are obviously odd numbers. The other thing we did mention was that it will actually work for consecutive odd numbers, consecutive even numbers, consecutive multiples of 10, consecutive multiples of 5. It'll work for any times table. So if you wanted to work out what the total of the first 5 numbers in the 6 times table are, 6, 12, 18, 24, 30, you just multiply the middle one, 18, by 5. 18 times 5 is 90. So basically, as long as there's the same gap between the numbers in the sequence, the strategy will always work. So you can play around with that. Again, it is really nice for your times tables if you've got to work out, the total of any numbers, consecutive numbers within the tables, consecutive multiples of 4 or consecutive multiples of 7. The same strategy will still apply. Don't want to spend too long on these because obviously this is a little bit of repetition, but it just gives you that opportunity to practice the greater depth skills, but this time with 5-digit numbers. As before, if we divide each of those numbers by 5, that will give us the middle number of the 5 consecutive numbers. So 25 divided by 5 puts 5 in the middle. 3, 4, 5, 6, 7. 40 divided by 5 gives us the 8 in the middle. 60 divided by 5 means it must be 10, 11, 12, 13, 14. 100 divided by 5, the middle number must be 20. So you've got a really nice string of numbers there that added together to make 100. And a tricky one at the end, 545. What's a fifth of 545? It's 109. Therefore, that's the number that goes in the middle. The strategy just remains the same. We're just working backwards again. Okay, the final part of these little tips and tricks for the day is when we're adding 4 or 6 consecutive numbers. Now, what you'll probably realize there is no middle number. So we said there's no actual middle number, but there are 2 middle numbers. 2, 3, 4, and 5. If you add the 2 middle numbers, 3 and 4, that gives you 7. There's obviously another pair of 7s on either side, so you just double it to get the answer 14. Interestingly though, if there was a middle, if there was a median to that, the middle of 3 and 4 is actually 3.5, and the strategy would work. So the middle of that set of numbers would be 3.5. If you multiply that by 4, you do get the answer at 14. 7, 8, 9, and 10. 8 and 9 is 17. Double is 34, which is the same as 8.5 times 4. And then you go to 6 numbers. How does it alter here? Well, again, you take those middle 2. 5 and 6 is 11. And you can see that there's another pair of 11s, 7 and 4, and another pair of 11s, 8 and 3. So what you're doing really is you're adding them together and then multiplying by 3, because there's 3 pairs of numbers there. If there is 8 numbers, you add the 2 middle ones and multiply by 4. If there's 10 numbers, you add the 2 middle ones and multiply by 5. So there's always a strategy. And this should really, really help in the future if you're ever being asked to add a string of any number of consecutive numbers. Look at that one there. 8, 9, 10, 11, 12. 10 and 11 is 21. Multiplied by 3 is 63. And that brings us to the end of part 1. Some of you may wish just to stop here, having taken quite a lot on board today and looked at basically lots of ways to develop using consecutive numbers and finding a total for just strings of 3, 5, 7 numbers and so on. If so, I'll see you tomorrow on Wednesday the 29th of April for a session on number bonds. If you want to look a little bit further and go into greater detail, please have a look at video 2, part 2 for today, in which we'll be looking again at slightly higher level strategies for longer strings of numbers, and also looking at a little idea for finding number bonds to 1,000 as well. So if you do want to take this learning a stage further, please have a look at video 2 and you'll be able to continue the learning there. Otherwise, I'll see you for the next part tomorrow when we look at number bonds. See you then.